Okay, so we're working out PMCC, and now we're going to start looking at the regression line. So this is putting everything together with what you did in the Year 1 section about interpreting the regression line. So we look at the question about coats of paint and protection. So it says the relationship between the number of coats of paint applied to a boat and the resulting weather resistance was tested in a lab. The data collected is shown in the table. Okay, so we've got coats of paint and protection in years. So the first question is, which one is the response variable? So remember, the response variable is the dependent variable. So in this case, it's going to be the protection. Okay, because the number of years of protection is dependent on how many coats of paint there are. Okay, right, so we calculate the PMCC and we're going to look at the regression line this time. We're going to work out the regression line of y on x. Okay, so you're going to press your menu and then press number 6 and then press number 2 to get y equals a plus bx. Okay, so then you need to input the x values 1 to 5 into the first column and then input the y values into the second column. When you've done that, you're going to press option and then you want number 4, the regression calc. Okay, so you should have got R equals, I actually think it's 1.00 to 3 sig figs. It's 0.9995, I think it is. So to 3 sig figs, it's pretty perfect. Okay, so we have got almost perfect positive correlation between the number of coats of paint and protection. As the number of coats of paint increase, the protection increases. Now on your calculator, you will also have values for A and B. A is the intercept, B is the gradient, y on x, y equals A plus bx. So remember, whatever's here is the response variable and whatever here is the independent variable. Okay, so on the previous one, if you were doing trees, it'd be C on H, so it'd be C equals A plus BH. If it was this one, for the history test, where you got your moderate correlation, it would be S on H. So it'll be S equals A plus BH. Okay, so whatever is here, this is the response variable. So we've got protection. Okay, so your calculator will have given you your A and B values. So if we do that to 3 sig figs as well, so a consistent 2.93 plus, and then your value for B, you should have got 1.45x. Okay, and then it asks us to interpret each variable. Okay, so each of these, if you're asked to interpret the variable, you have to interpret them in the context of the question. So if you had to interpret that with 2.93, remember that's the intercept. So the intercept is the value of the response variable when the explanatory variable, this variable, is 0. So 2.93 will be, if we write that down, it's going to be the number of years of protection. So it's the number of years of protection when no paint is added. So in other words, when x equals 0. So that's what the intercept is. Now in this case, that makes numerical sense. Sometimes it doesn't make numerical sense, but remember, we're only draw our regression line through the data. We don't necessarily force it to go to the intercept. So they won't always ask you to interpret the intercept because it doesn't make sense a lot of the time. The 1.45, well, that's the gradient. And the gradient, remember, just a gradient is for every 1 unit this increases by, this is going to go, in this case, up by 1.45. Okay, if this was a minus, then this would go down by 1.45. So it's always, I would always start with for every 1. So it's for every 1 unit, which in this case is a coat of paint. For every 1 coat of paint, in this case, this unit is years of protection. The years of protection increases because it's a plus by 1.45 years. Okay, so the intercept is what's happening to the response variable when x equals 0. The gradient is what's happening to the response variable for every 1 more of those. So always start off, if you're interpreting the gradient, with those 3 words, for every 1. Okay, right, I would like you to pause the video and work out the PMCC and the regression line for the newborn turtles. Okay, so you should have got R equals 0.511 and the regression line of W on L, W equals, I've just realised that's not right. I think it's 0.926. Okay, I don't actually know what the regression line is because I have not written it down. Okay, so you should have found that you have got strong positive correlation between the weight and the length. So as the length of the baby turtle increases, the weight increases. There is strong relationship between those 2 variables. Okay, so the last question that we're going to look at on this video now links the first video with PMCC and regression. So it's all in one. So we've got data that is being coded. It says the width and the mass of snowballs are measured. So we've got width and mass, W and M, they are the variables. The table below shows the data. There it is. The data are coded using x equals log W and y equals log M. So the first thing you're going to do is you're going to code the data. So we're actually physically coding the data this time. So you're going to do log to base 10 of 3, round it to 3 decimal places. Let's all do 3 decimal places so we've all got the same answer. And that goes in there. And then you're going to do log to base 10 of 4, and that's going to go there, and so on until you've done log to base 10 of all those numbers. So just pause your video and fill that table in. So I'm just filling this in. So you just check your numbers. I've just rounded each one to 3 decimal places. Okay, so the data has been coded. So then it says, calculate the PMCC for the coded data. So you are going to now use your calculator to work out the PMCC for that data. So not for this data here. So pause the video again and work out the PMCC for that data there. Okay, so you should have got R equals, again, it's 0.9996, so 1.00 to 3 sig figs. Okay, so it's almost perfect correlation. So we've started off with some data, and by coding it, we've ended up with almost perfect correlation. So it says, with reference to your answer to B, so this, state whether a model in the form y equals kx to the n would be a good fit for the data. So it's asking why, because we've got this value here, this would be a good model. So if you remember what I said in the first video, I said if you code data and you end up with a straight line, then that means that the data to begin with must have been curved. So because by coding the data we've ended up with a linear relationship, then the data must have been curved to begin with. So that's what we can write down. So for part C, so since, this is what I've written, so since coding has produced a linear relationship, the curved model y equals kx to the n is a good fit. Okay, so that's all I've written. And then it says, for the last part, determine the values of k and n. So we now need to do what we did before, where we are going to code this and match it up. Now, in order to match it up, we need the regression line. So I'm hopefully you've not wiped it off your calculator. Okay, you've got your coded data in. You've got your coded PMCC. You've also, with your value of A and B, you can write down your coded regression line. So A was 0.464 and B was 1.88. Okay, both of those are to 3 sig figs. So the regression line is 0.464 plus 1.88x. Now what we're going to do is, same again, what we did in the first video, we're going to code our data. Now before we code our data, just going to change the variables, because if you look, we want it in this form, but y and x aren't our variables. W and M are. Okay, so I don't want to have confusion over all the letters that are going on. We want it to be in this form, but we're not having y and x, we've got w and m. Okay, so actually instead of that, it's m equals kw to the n. That's what our equation is going to be for mass against width. So I've changed the variables so it's right. So I'm going to code this. So log m equals log kwn. Split that product up. I'm just going to do two in one. Split the product up and also bring down the n at the same time. Okay, so then underneath that I can write down my regression line, which is here. So this is the curve, which is what we're trying to find. We've coded the data and we've got our regression line. So it's going to be y equals 0.464 plus 1.8x. Okay, the k and the n are the constants. That's a constant, so that must be the intercept. That's a constant, so that must be the gradient. Have I missed a number off? I have. Another 8 in there. Okay, so that's the gradient, which means the n must be 1.88. And then if I make log to base 10 of k equal to 0.464, remember this is now in log BAP form, so base, answer, base, answer equals power, so base, power equals answer.